Good day, everyone. Welcome to Fame Global Academy. And I'm your chemistry instructor, Mr. Michael Osai. Today, we shall be looking at UTM questions based on the topic known as IUPAC nomenclature of organic compound. This is a branch of chemistry that seems to be a kind of nightmare to students, but I can assure you, with Fame Global Academy, we are here to provide solutions to challenging areas as regards this topic. Now, IUPAC nomenclature, or the word nomenclature, simply means naming, and IUPAC is a chemistry body established and saddled with the responsibility of giving accurate name, or better still, correct naming to organic structures and organic compound by utilizing or by making use of certain rules or better still principles. So in this class today, we shall be applying those rules where necessary as regard the questions that we'll be answering today. All right, we have a question on the board that says the IUPAC nomenclature of the compound is what? Say we are asked to give the IUPAC name of the structure above. Now we have options on the board. We have A, 2-chloro, isopentane. Then we have B, 3-chloro, isopentane. Then we have C, 2-chloro, 2-methyl, 2-chloro, 2-methyl butane. Then we have D, 1-chloro, 2,2-dimethyl propane. All right, let's look at this question on the board. The question says, give the IUPAC name of the structure above. We have a structure on the board. How do we go about answering this type of question? One of the rules or principles guiding the IUPAC nomenclature of organic compound simply states that you must locate what we call the longest carbon, is the root carbon that will bear the parent name of a particular homologous family. Now look at this structure on the board. Let's try to locate the longest carbon containing chain. You can do this from any direction. You can do it from this end backward. You can equally do it from this end backward. Sometimes you can locate it from below, then sideways, or from the top, then sideways, as the case may be. Looking at this structure critically, you agree with me that the functional group in this structure is single bond. Is what? Single bond. And the homologous family that has a functional group that is single bond is what we call the alkane family. Let's locate the longest carbon containing chain. From this end, we have 1, 2, 3, 4. Then we have 1, 2, 3, 4. We can also have 1, 2, 3, 4. So the longest carbon from any direction is 4. But where must we start numbering from? The accurate direction to start numbering from is from this end. I'll give you reason. 1, 2, 3, 4. Let's assume that a student chooses to number from this end. 1, 2, 3, 4. That student is wrong. Do you know why? Because at the point where we have what we call substituent or branch, it is quite the distance is more from this end, but the substituent, they are closer from this end. So at carbon atom 2, we have the what? The substituent, which are what? Chlorine and methyl at carbon atom 2. So it's closer from this end. But if you want to take it from this direction, we have 1, 2, 3. The distance is small. So the correct direction to locate the longest carbon containing chain is from this direction. So we have 1, 2, 3, 4. The next thing is to what? To identify the substituent, or better say what we call the branch. We have 2 branch or 2 substituents in this structure. One is an inorganic substituent, while the other is an organic substituent. Both of them are at carbon atom 2, as we can see on the board. One of the rules or principles guiding IUPAC nomenclature equally states that having identified the longest carbon containing chain, which is the root carbon that will bear the parent name of a particular homologous family of this alkane, the next is to mention or name the inorganic substituent ahead of the what? Organic substituent. What does that mean? Let's name 1, 2. At carbon atom 2, there's a chloro, which is an inorganic substituent. So it simply means we must mention the chloro first with respect to the position of the carbon atom. And we have 2 chloro. This 2 simply means at carbon atom 2, that's where we have the inorganic substituent called chloro. Then before you go ahead to name the organic substituent, at carbon atom 1, 2, at carbon atom 2, we have what? A methyl group. This is what we call a methyl group. So you say 2 chloro, 2 methyl. Then before you go ahead to name the longest carbon chain, which is 1, 2, 3, 4. And that is what we call, say, butane. So we have 2 chloro, 2 methyl, butane. So the correct answer to this question is option C, 2 chloro, 2 methyl, butane. All right, are you following me? I hope this is simple enough. If you are just joining us, this is Fame Global Academy, and today we are answering UTME question based on the topic known as IUPAC nomenclature of organic compounds. Let's take a look at another question here. The question says, give the IUPAC nomenclature, or give the IUPAC name, give the IUPAC nomenclature of the structure. We have CH3, CH3, and we have CH2, we have CH, and we have double bond CH2. Then the options are, this question is gotten from 2013, question number 49. We have A, 2 methyl pent 1N. We have B, 2 methyl pent 4N. Then we have C, 4 methyl pent 1N. And of course, we have D, 3 methyl pent 2N. All right, let's look at this question. We have a question on the board again that says, give the IUPAC nomenclature of the structure as we have it on the board. Like I said, rule number 1 is to what? To locate what we call the longest carbon containing chain, which is what? The root carbon of the parent name of a particular homologous family. And I said you can do that from any of the direction. But let's look at this structure now. Let's try to identify the longest carbon containing chain. We have 1, 2, 3, 4, 5 from this direction. We can have 1, 2, 3, 4, 5 as well. We can equally have 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. Having identified that we have 5 carbon atom as the longest carbon in this structure. So it simply means that the parent name must be pentane, must be a pent, okay? Then the next thing is to identify the functional group in this structure. You will agree with me that the functional group in this structure is the double bond, and the homologous family that have this double bond functional group is the alkane family. Is the what? Alkane family. So the parent name must end with pent 1N. Pent simply means 5 carbon atoms. Then this double bond is for or represent the functional group of a particular homologous family known as alkane. So the ending aspect must be in. Then let's go ahead to locate the branch in this structure, then we name accordingly. Having identified the longest carbon containing chain, the next thing is to identify the functional group. And again, not just identifying the functional group, but the direction at which the functional group is closer to the first or second carbon atom, as the case may be. And as such, you must number from that direction. Looking at this structure critically, you can see that at carbon atom 1, that's where we have the functional group. So it's very wrong for you to start numbering from this end. 1, 2, 3, 4. At carbon atom 4, that's where we have the functional group from this direction. So the correct direction to start numbering, to locate your longest carbon chain, is from this direction. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, what? 5. 5 carbon is what? Pent. Then this functional group, double bond, is for the in family, alkene family. That's why we have E here at the terminal of the what? Of the naming of the what? Of the structure. Then again, having identified the longest carbon from this end, 1, 2, 3, 4, 5. The next thing is to identify the branch in the structure. Where is the branch, or what is the branch in the structure? We have just one branch in the structure, which is this organic substituent called methyl. Called what? Methyl. So let's name now. From this end, so we must take it from this end because we have located our longest carbon containing chain. Let's go now. 1, 2, 3, 4. At carbon atom 4, we have our organic substituent called methyl. Called what? Methyl. So we'll now name like this: 4-methyl, 4-methyl. Then the longest carbon is what? 5. That is 4-methyl pent. Where do we have the functional group? Double bond. The functional group double bond is at carbon atom 1, and as such, you name it as pent 1. Then this double bond, the homologous family is alkene family, which ends with En. You now say pent 1 in. Pent 1 what? In. Let me draw our attention to something again. These numbers that you are seeing is showing us the position, or the indication, the position of the alkyl group, which is the what? The substituent. Where is this methyl found? This CH3, which is a what? Methyl. So it's found at carbon atom 4. And so you say 4-methyl, then the longest carbon bears the what? The parent name, which is pent. And of course, the double bond is at carbon atom 1. That's why we have 1. Then we use the word in, because double bond is the functional group of the homologous family known as alkane. Are you following us? If you are just joining us, this is Fame Global Academy, and today we are attending to questions as related to what we call IUPAC nomenclature of organic compounds, and we are answering UTME questions. Let's take yet another question here. So we have another structure here. We have HCHO. We have HCCl, HCHBr, then we have CHH. All right, the options we have here, we have 2-bromo, 3-chloro-butanol, and we have 3-bromo-2-chloro, 3-bromo-2-chloro, 3-bromo-2-chloro-butanol, and we have 3-chloro-2-bromo-butanol, and of course we have D, 2-chloro-3-bromo-butanol. All right, let's look at this structure. The question says, give the IUPAC nomenclature of the structure. We have, as we have it on the board, the first rule I just stated is try as much as possible to locate the longest carbon containing chain in the structure, which is the root carbon that will bear the parent name of a particular homologous family. And secondly, identify the functional group in the structure. In the what? Structure. Then proceed again to identify the branch in the word structure. Is it an organic branch or an inorganic branch? Looking at this structure on the board critically, you agree with me that the number of carbon atom or the longest carbon containing chain from any end, 1, 2, 3, 4, better still 1, 2, 3, 4 is 4. That is what? Carbon atom 4. And carbon atom 4 in organic chemistry is what? Say boot. All right, having seen that, the next thing is to identify the functional group. The functional group here is the HO or OH. We call it hydroxy functional group from a homologous family known as the alkanols. Known as the what? Alkanols. They have OH functional group. OH or OH or HO functional group. Now, the inorganic substituents here are chlorine and bromine. One of the rules guiding the IUPAC nomenclature of organic compound states that if you have a mixed substituent, or better still, if you have a functional group and also an inorganic substituent appearing in a particular structure as we have it on the board, you must give priority or preference to the functional group ahead of the inorganic substituent. What does that mean? It simply means that trying to locate our longest carbon containing chain, we must come from this end where the what? The functional group is closer to the first or second or third carbon atom, as the case may be. Look at this structure on the board. The functional group is at carbon atom 1 from this end, but from this end, 1, 2, 3, 4, the functional group is at carbon atom 4. So it is wrong for us to start numbering our longest carbon containing chain from this end. Did you get what I just said? I just said you must give priority to functional group ahead of any other substituent or branch in trying to number the longest carbon containing chain to locate our root carbon, which will bear the parent name. Now, having seen that, we have a mixed inorganic substituent here, a chloro and a bromo. Chlorine, when it's present in an organic compound, we call it chloro, while bromine, when it's present in an organic structure or compound, we call it bromo. Are you following me? Let's name accordingly now. Now we have, I just said, if you have a mixed substituent or a mixed branch, you must name alphabetically. Having identified the direction in trying to number the longest carbon chain from this end to this end, the next is that we must mention chloro before bromo. Looking at this structure, you agree with me that chlorine, which is chloro, is at carbon atom 2, while bromine is at carbon atom 3. So B comes before C alphabetically. So the correct name to this structure is 1, 2, 3. 3 bromo, 1, 2. 2 chloro, 1, 2, 3, 4. Longest carbon. Butanol. 3 bromo, 2 chloro, butanol. B comes before C alphabetically. So the correct answer to this question is 3 chloro, 2 bromo, 3 bromo, 2 chloro, butanol. 3 bromo, 2 chloro, butanol. That's option B. 3 bromo, 2 chloro, butanol. All right, if you are just joining us, this is Fame Global. You can do well to subscribe to our YouTube channel if you have not done that. We are still there on Instagram, on Facebook, and on TikTok. And today we are answering UTME question based on the topic in chemistry called IUPAC nomenclature of organic compounds. So this is the simple way of going about naming this type of structure. Let's take some more. We have another structure on the board. Okay. Then we have option A. This is taken from or gotten from 1993, question number 42. We have a dimethylhexane. We have B, 3,5 dimethylpentane. Then we have C, 3-chloro, 2-bromo. Okay, we have C, 1,1-dimethyl, 3-methyl. Then we have D, 2,4-dimethylhexane. All right, let's look at this question on the board. The question says, give the nomenclature of the structure as we have it on the board. The first rule, like I said earlier on, is locate the longest carbon containing chain from any direction. From where? From any direction. Then identify the functional group in the structure. Looking at this question closely, you will see that the functional group is single bond. The functional group here is what? Single bond. And so the homologous family that bears single bond as its functional group is the alkane series. Is the what? Alkane series. Let's try as much as possible to locate our longest carbon containing chain, which is our root carbon that will bear the parent name of a particular homologous family. From this end, we have 1, 2, 3, 4, 5, 6. From this end, we have 1, 2, 3, 4, 5, 6. We can also have 1, 2, 3, 4, 5, 6. We can have 1, 2, 3, 4. This is short. 1, 2, 3, 4, 5, 6. This is long. 1, 2, 3, 4, 5, 6. So we have the longest carbon as any end. From where? From any end. 6 carbon atom is what? Say hex. 6 carbon atom is hex. The next thing is, haven't seen from the two ends the direction where we have the longest carbon containing chain, but where is the most appropriate or correct to start numbering from. If a student chooses this direction, 1, 2, 3, 4, 5, 6, and another student chooses this direction, 1, 2, 3, 4, 5, 6. This particular student is wrong. Why? Because the first branch from this end is at carbon atom 4. It is quite, the distance is small. But from this end, the first branch is at carbon atom 2. So you must start numbering from this end to this end. You start numbering from the end where the branch is closer to the first second carbon atom. And let's look at this now. So we have 1, 2, 3, 4, 5, 6. 6 carbon is what? Hex, like I just said. But at carbon atom 1, 2, there's a methyl. At carbon atom what? 2, there is a methyl. Then at carbon atom 1, 2, 3, 4, there's another methyl. There's another what? Methyl. So how do you write this? Because it appeared twice, but in two different positions of carbon atom 2 and carbon atom 4, how do you go about writing the name now? Now say 1, 2, 2, 1, 2, 2, then 1, 2, 3, 4, 2, 4. Because it appeared twice at carbon atom 2 and carbon atom 4, you use the prefix called, say, di. Then before you now name dimethyl, then of course you put the parent carbon, which is called hexane, which is called what? Hexane. Let's look at or let's pick our correct answer there as we have it on the board. That is option D. 2,4-dimethyl-hexane. 2,4 what? Dimethyl-hexane. If you're just joining us, this is Fame Global Academy, and we enjoy you this morning to follow us closely while this class is in progress. You can subscribe to our YouTube channel. We are still there on Facebook, on TikTok, on WhatsApp. If you have any question, you can ask us while the class is in progress, and we are here to provide answers to all your questions. We'll take yet another question here. We have another structure, CH3, CH2, 3, then CH, C2H5. Then we have option A, 5-propyl heptane. Then we have B, 3-propyl heptane. And we have C, 4-ethyl octane. Then we have D, 5-ethyl octane. All right, let's look at this question closely. We have a structure on the board and we are asked to provide the IUPAC name of the structure. Repeatedly, I've set rules that first of all locate the longest carbon containing chain in the structure. But look at this structure. We have certain atoms in bracket. What does that mean? So it simply means that we have 3 atoms of carbon in this structure. This is what we call the condensed structure of an organic compound. So let me try as much as possible to open it so that we'll see the full structure, and that will help us to understand what we are expected to do properly. This is CH3. You can do something like this, CH3. Then we have anything outside the bracket multiplies everything inside the bracket. So it simply means that we have additional 3 carbon atoms in between. So what does that mean? So you have to insert 3 other carbon atoms in between. Then we have 6 hydrogen atoms. 2 times 3 is 6. Then the carbon atom is 3. 1, 2, 3. Let's put the hydrogen atom. 1, 2, 3, 4, 5, 6. Are you following me? Then this carbon now, we're now bond with this carbon. Then of course this carbon is bearing H here. Then it's bearing C3H7. We can equally extend this C3H7 if we want to. But let's leave it out first. And of course we have C2H5. C2 what? Let's try as much as possible to locate our longest carbon containing chain. From this end we have 1, 2, 3, 4, 5, 6, 7. Then from this end we have 1, 2, 3, 4, 5, 6, 7, 8. We have 3 carbon here. We can equally have 1, 2, 3, 4, 5, 6, 7. Please note, the longest carbon is not 7 in this structure. This is the mistake that most students make. They are always fond of either trying to locate the longest carbon chain from this end to this end and from this end to this end. It doesn't work out that way all the time. You can try to locate it from down here upward, or better sometimes from upward sideways then down. Looking at this structure, you can agree with me that the longest carbon is 7. It's 8 and not 7. And let's try and locate it. So we have 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. Are you following me? So the longest carbon is 8. And 8 in organic chemistry is what we call oct. Is what we call what? Oct. The next thing now, having located the longest carbon containing chain, the next thing is to locate where a particular branch is closer to the first carbon, second carbon, as the case may be. Now, if we come from here, 1, 2, 3, this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. Are you with me? Now we have 1, 2, 3, 4. Carbon atom 4. We have this as a branch. Mind you, if I've taken this direction as my longest carbon chain from this direction to this direction, of course, here now becomes our branch. Here now becomes what? Our branch. If I take this direction to this direction, here becomes our branch. Are you following me? So we have 1, 2, 3, 4. A carbon atom 4, we have a branch. We have a what? Branch. This branch is what we call, say, ethyl. You know, CH3 is what? Methyl. The next one is what? C2H5 is ethyl. Are you with me? Now, this C2H5 is ethyl. Where is it located? It's located at carbon atom 4. Mind you, I said 1, 2, 3, 4, 5, 6, 7, 8. Where is it closer? This attachment. A carbon atom 4 is closer. But from this end, we have 1, 2, 3, 4, 5. It will be a carbon atom 5. So we can't start numbering from this end. The correct direction to start numbering from is from here. 1, 2, 3, 4. This attachment is closer. So you now say 4, a carbon atom 4. We have the ethyl, 4 ethyl, then the longest carbon. 1, 2, 3, 4, 5, 6, 7, 8. Oct. The functional group here is single bond in the alkane family. You now say octane. You now say what? Octane. So the correct answer to this option, to this question is 4-ethyl octane. Are you following me? If you are just joining us, this is Fame Global Academy, and we are answering UTME questions as related to the topic known as IUPAC nomenclature of organic compound. Please, if you have any question, please do it to ask us. We are right here to answer you. We'll take yet another question. We have a structure on the board again. We have CH3, CH2, CH3, double bond CH, CH2, CH3, CH3. We have A, 2-ethyl, 5-methyl hexane. Then B, we have 2,5-dimethyl hex 2-ene. Then C, we have 3,5-dimethyl hex 3-ene. Hex 3-ene. Then of course we have D, 3,6-dimethyl 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 hex 3-ene. All right, we have yet another question on the board, and this question is extracted from 1992, question 46. Question 42. All right. We have another structure on the board. We are asked to give the IUPAC nomenclature. IUPAC nomenclature of organic compound. And I have said earlier on that the first thing to do is to locate what we call the longest carbon containing chain, which will be the root carbon that will bear the parent name of that particular homologous family. And secondly, I have said that the next thing is to identify the functional group in the structure. Again, go ahead to identify the substituent or the branch in the structure. If you have a mixed structure where you have a functional group and as well as whether organic or inorganic substituent, you must give preference to the functional group in an organic structure while trying to locate your longest carbon containing chain, which will be the root carbon. Are you following me? So I want us to follow us closely as we answer this particular question on the board. Looking at this structure, let's try to locate our longest carbon containing chain from any direction. We have 1, 2, 3, 4, 5, 6 from this end. 1, 2, 3, 4, 5, 6 from this end. We have 1, 2, 3, 4, 5, 6, 7. And we have 1, 2, 3, 4, 5, 6, 7. So this automatically nullifies this direction. From this end to this end and from this end to this end has been nullified because the longest carbon here is 1, 2, 3, 4, 5, 6. Then from here is 1, 2, 3, 4, 5, 6. Well, now we have a direction where the longest carbon is not 6, but rather it is 7. Either from this end, 1, 2, 3, 4, 5, 6, 7, or from this end, 1, 2, 3, 4, 5, 6, 7. Having located our longest carbon as C7, of course, 7 in organic chemistry, what we call say hept. Hept. Are you with me? Then the next thing is to identify the functional group. Where is the functional group closer to the first, the second, or the third carbon atom? Now let's go from this end. 1, 2, 3. At carbon atom 3, we have our functional group, double bond. Let's go from this end. 1, 2, 3, 4. At carbon atom 4, we have it from this end. Are you following me? So the correct direction is from this end. 1, 2, 3, 4, 5, 6, 7. Why? Because at carbon atom 3, we have our functional group double bond. But if you take this direction, 1, 2, 3, 4, it will be a carbon atom 4. So the distance is small from this end. You always take it to from the distance or from the point where we are having the lowest possible number. So the correct numbering to locate our longest carbon containing chain in this structure is from this end. 1, 2, 3, 4, 5, 6, 7. If we have taken this direction to locate our longest carbon containing chain, it means that the branch in this structure is this part and this part. Are you following me? Having located the longest carbon containing chain, please, that part will no longer serve or act as a branch. What do I mean? Look at our longest carbon containing chain. 1, 2, 3, 4, 5, 6. So it means that a carbon atom 3, then a carbon atom what? 6, we have another branch, methyl. Then before we now have the 7th carbon that completed or that completes the longest carbon chain. Are you following me? I mean, so this progression or direction from this end, 1, 2, 3, 4, 5, 6, 7, longest carbon containing chain. Automatically here becomes our branch and here becomes our branch. So the next thing is to make effort to name the branch in this structure. To name what? The branch in this structure. All right, let's go. 1, 2, 3. A carbon atom 3, there's a methyl. Then a carbon atom 4, 5, 6. A carbon atom 6, there's another methyl. Are you following me? A carbon atom 3, there's a methyl. See 3. Then a carbon atom 3, 4, 5, 6. A carbon atom 6, there's another methyl. Say 3, 6. Because methyl appeared twice as a branch in this structure, you now use the prefix, say di. Then before you now name the methyl, and of course, our longest carbon is what? Hept. But don't just be in a hurry to complete the naming. No, we now have hept. Another thing that you should be able to figure out is this functional group double bond is for the homologous family called alkene. Where is it located in this structure? So looking at this structure closely, you agree with me that the functional group double bond is a carbon atom 3. It's a carbon atom what? 3. We have 1, 2, 3. A carbon atom 3, we have the double bond functional group. So you name accordingly and apply it. You now say hept 3, because the functional group is a carbon atom 3. Which functional group? Say the in functional group for double bond, which is what? Which is peculiar to the in family, to the inward family. So the correct answer to this structure is option D. 3,6-dimethyl hept 3 in. What does it mean? A carbon atom 3, there's a methyl, which is this. Look at it. 1, 2, 3. A carbon atom 3, there's a methyl. Then a carbon atom 6, 1, 2, 3, 4, 5, 6. There's another methyl. It appeared twice. So you say 3,6 showing us the position of the methyl. And because it appeared twice, you make use of the prefix di-methyl. Then the longest carbon from this end, as we have traced it, is hept. Are you with me? 7 carbon atom. Then this 3 is showing us the position where the double bond functional group is located is a carbon atom 3. Then of course, the family that has double bond as their functional group is the alkene family. And that's why the ending will end with E. Are you following me? I hope you are understanding what we are studying or learning this morning. Once again, if you just join us, this is FAME Global Academy, where UTME chemistry questions is what? Or they are simplified. We are going to take yet another question, but I want to join us to what? Kindly subscribe to our YouTube channel if you have not done that. We are still there on Instagram, Facebook, and TikTok. If you have any question, please do it to ask us, and we are right here to answer you. We'll take more questions. All right. Okay, this is quite very simple. We have a structure on the board. This one is gotten from 1991, question number 48. Then we have A, 1-chloro, 2-methylbutane, and we have B, 1-chloro, 2-methylpropane. Then we have C, 2-chloro, methylethane. And we have D, 1-chloro, 2,2-dimethylethane. All right. We have another question on the board. This one is quite very simple to answer. We have this correct IUPAC nomenclature of the organic structure as we have it on the board. The first thing, like I said, locate the longest carbon containing chain, which is our root carbon that will bear the parent name of that particular homologous family. And secondly, locate the branch that is in the structure. Is it an inorganic branch or an organic branch? And take note of the position. Then let's look at this structure now. You will agree with me that the functional group in this structure, is single bond. Is what? Single bond. And single bond is peculiar, or is a functional group of the homologous family called the alkane. Called what? The alkane. Let's look at the longest carbon from any direction. We have 1, 2, 3 from this direction. We have 1, 2, 3 from this direction. We have 1, 2, 3. Then we have 1, 2, 3. It simply means from any end, we are having 3 carbon, and 3 carbon is what? 3 carbon is what? Say prop. Are you with me? But let's look at the direction we must start numbering from. The direction that we must what? Start numbering from. From here we have 1, 2. Then from here we have what? 1, 2. We must start numbering from here. 1, 2, 3 is correct, or 1, 2, 3. I'll give you a reason why we must start numbering from here. If we start numbering from here, it simply means that this chlorine is a carbon atom 1, which is a what? Which is an inorganic branch or substituent in this structure. We must start numbering from here 1, 2, 3, or 1, 2, 3. We must not start from here, because if we start from here, we have 1, 2, 3, a carbon atom 3. We have the inorganic substituent, or 1, 2, 3. Of course, that one is still quite very far. But if you look at this structure very well, you see that a carbon atom 1, we have a chloro. So the chloro is closer in this structure at carbon atom 1 from any end. From what? Any end. And as such, you must start numbering from here. 1, 2, 3, or 1, 2, 3 is correct, because from this direction, 1, 2, 3, then 1, 2, 3. Any of this is equal from this direction. So we have 1, 2, 3. If you have taken 1, 2, 3 as our direction, automatically here becomes our branch. Here becomes what? Our branch. Are you following me? A branch will not form part of the longest carbon containing chain. Having identified your longest carbon containing chain, any other part becomes the branch, becomes the what? Branch. So we are taking this direction, 1, 2, 3. So our branch in this structure is here and not here anymore. Are you with me? So a carbon atom 1, we have a chloro. You now have 1 chloro. And a carbon atom 1, 2. A carbon atom 2, we now have our branch again called methyl. Called what? Methyl. Now say 1, 2. 1 chloro, 2 methyl. 2 methyl what? The longest carbon is what? 1, 2, 3, which is prop. And I say propane. Are you with me? Hope you are understanding what we are learning this morning. We have 1 chloro, 2 methyl propane. Are you with me? All right, we'll take more questions. Are you packing for the carbon? We have another structure. CH3. CH3. We've done this before. 2-ethyl, 4-methyl, pent 2-ene. That's A. B. We have 3,5-dimethyl X3-ene. Then C. We have 2,4-dimethyl X3-ene. I think we've answered this before. 2-methyl. It came out again. 4-ethyl pent 3-ene. All right, let's look at this structure on the board. The question says, give the IUPAC name of the structure above. Like I said, the first thing is to locate the longest carbon containing chain in this structure. Then identify the functional group in the structure. Now we have 1, 2, 3, 4, 5, 6. I think this appeared again in a different year, 1990, question number 43. 1990, question number 43. Okay. The longest carbon in this structure is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then we have 1, 2, 3, 4. 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. Then we have 1, 2, 3, 4, 5, 6. Then we have 1, 2, 3, 4, 5, 6. All right. Are you with me? The next thing is to locate where we have the functional group closer to the first or second carbon atom. From this end, we have 1, 2, 3. At carbon atom 3, we have the functional group. And at carbon atom 1, 2, 3, we only have the functional group. So we can come from any end. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. But what about the branch? Where is it closer? Look at this structure. We have given preference to functional group. But the only difference is that from this end, the functional group is at carbon atom 3. In the same vein, from this end, 1 to 3, the functional group is at carbon atom 3. So we'll now look at another rule or principle, because from both ends, the functional group is at carbon atom 3. So what we'll give preference again now, having given preference to functional group, is where is the branch closer to the functional group? Where is the branch closer? Let's look at it. 1, 2, 3. If we are taking this direction, 1, 2, 3, here will now become our branch. But if we are taking this direction, if we are taking this direction, I mean, if we are taking this direction, 1, 2, 3, carbon atom 3 will have our branch. But if we are taking this direction, 1, 2, a carbon atom 2 will have our branch. So we must start naming from the side where the branch is having the smallest possible number. Did you get what I just said? Now, I said from both ends, from here to this end and to this end, the functional group is at carbon atom 1, 2, 3. From here, it's at carbon atom 1, 2, 3. The next thing to consider now is look at our branch now and look at another branch. Where is the branch closer? Where is the branch what? Closer. Now we have 1, 2, at carbon atom 2, we have our branch. But from this end, 1, 2, 3, at carbon atom 3, we have our branch. We must start end. We must start numbering from where? From this end. We have 1, 2, 3, 4, 5, 6. Are you following me? Now you're listening. At carbon atom 1, 2, we have a methyl. Carbon atom 2, we have a methyl. Then 1, 2, 3, 4. Carbon atom 4, we have another methyl. That is 2, 4. It appears twice. Dimethyl. Then our longest carbon is what? 1, 2, 3, 4, 5, 6. And of course, 6 carbon is what? Say hex. We have hex. Then our functional group there is what? Double bond. Is what? Double bond. That family is what? Alkane family. That's the family that has a functional group of double bond. And the double bond is a carbon atom what? 1, 2, 3. A carbon atom 3. We now say hex 3 in. Now the 3 is showing us the position of the functional group double bond, which is peculiar for the in family, for the what? Alkane family. So the correct answer to this question is 2,4-dimethyl hex 3 in. Are you following me? If you are just joining us, this is Fame Global Academy. If you have not subscribed, please kindly subscribe to our YouTube channel. You'll be seeing live videos on teachings and the way we answer UTME questions. Then we simplify it for you. We're also there on Facebook, on TikTok, and on Instagram. And we'll take more questions. All right, look at this structure. We have CH2, double bond C, CH3, CH2Cl. This one is gotten from 19, question number 48. So we have options A, 1-chloro, 2-methyl, prop, 2-terene. We have B, 1-chloro, 2-methyl, prop, 2-in. We have C, 3-chloro, 2-methyl, prop, 1-in. D, 3-chloro, 2-methyl, prop 1, 2, N. All right, let's look at this question. We have a structure on the board and we are asked to give the IUPAC name to that structure on the board. I just said the first thing is to locate the longest carbon containing chain from any direction. So we have 1, 2, 3 from this end. 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 But looking at this structure, the next rule, I said, identify the functional group in the structure, which must be given preference or priority in terms of numbering to locate our longest carbon containing chain, as we have it on the board. From this end, 1, 2, a carbon atom 2, we have the functional group. Then from this end, a carbon atom 1, we have the functional group. From this end, 1, 2, so a carbon atom 2, we have the functional group. From this end, 1, 2. But from this end, 1, 2, 3 is a carbon atom 1, we have the functional group. So our numbering must be from this end, either 1, 2, 3 or 1, 2, 3. But 1, 2, 3 is wrong. I'll tell you why. Are you with me? Haven't gotten the direction of our longest carbon, which is 1, 2, 3. I said 1, 2, 3 is wrong. Why? Because there's the presence of an inorganic substituent, which is acting as a branch at this carbon atom 3. Are you following me? And as such, you cannot number from here to here. Then the next thing is to, how do we name? We just saw that we have 1, 2, 3, 3 as our longest carbon, and C3 is what? Is prop. C3 is what? Prop. Are you with me? Then 1, 2, 3, a carbon atom 1, we have the what? Double bond functional group. So it will end with prop 1 in. Prop 1, 2, 3, 3 carbon. Then a carbon atom 1, we have the functional group double bond. So, but you must name this inorganic substituent first before you now complete this naming. What does that mean? 1, 2, 3, a carbon atom 3, there's a what? Chloro, there's a what? That's a 3 chloro before you now name prop 1 N. Okay, there's a methyl here. Sorry about that. Correction, please. Correction, please. I have 1, 2, 3. We have 3 chloro. Now, I just said 1, 2, 3. That's the longest carbon. So here automatically becomes another branch. Here becomes another branch. But this is inorganic substituent. And this is organic organic substituent. One of the rules states that you must mention or name an inorganic substituent before you mention an organic substituent. So the correct naming now is 1, 2, 3. Carbon atom 3, we have the true. Say 3-chloro. Then 1, 2, carbon atom 2, we have a methyl. 1, 2, carbon atom 2, we have a what? Methyl. Now say 2-methyl. Before I now name the 1, 2, 3, the longest carbon, which is prop. Carbon atom 1, we have the functional group prop 1N. Did you get that? You mention or name inorganic ahead of what? Organic. The inorganic is a carbon atom 3, which is chloro, while the organic is a carbon atom 1, 2, which is what? Methyl. So this shows us the position of the chloro or the chlorine and the position of the methyl. So you say 3-chloro, 2-methyl, prop 1N. Of course, we have 3-chloro, 2-methyl, prop 1N. Are you following me? I hope it's simple enough. So take yet another structure. I have CH3. CH. Let's take a look at this. We have A, 2-methyl, 3-pentane, B, 4-methyl, 2-pentane, C, 2-methyl, 2-pentane, D, 4-methyl, pent 2. Okay. All right, before we answer this question, if you are just joining us, this is Global Academy, and today we are handling questions as related to the topic known as IUPAC nomenclature of organic compounds, showing simple ways to name organic structures or organic compounds by applying the rule that is specific or peculiar to a particular structure as we have it on the board. Let's look at this question. The question says, give the IUPAC nomenclature of the structure, of the what? Structure. I just said before now that the first thing to do is to locate the longest carbon containing chain. Having done that, you identify the functional group in the structure. Let's locate our longest carbon. We have 1, 2, 3, 4, 5 from this end, 1, 2, 3, 4, 5 from this end, 1, 2, 3, 4, 5 from this end, 1, 2, 3, 4, 5 from this end. So you agree with me that an organic compound that has 5 carbon atoms is known as pent. It's known as what? Pent. Are you following me? The next thing is to identify where the functional group is closer to the first or second or third carbon atom. But looking at this structure, if we have taken this direction or this direction to locate our longest carbon containing chain, now at position, let me say 1, 2, 3, 4, 5. At position 2, we have our functional group. But from this end, at position 1, 2, 3 is where we have our functional group. Irrespective of the fact that we have an organic substituent, which is what? Methyl, carbon atom 2 from this end, we won't consider methyl ahead of what? Ahead of our functional group, double bond. So the numbering must begin from this end, 1, 2, 3, 4, 5. Why? We give priority to the functional group ahead of an organic or inorganic substituent. And that's how our numbering must start from this end. 1, 2, 3, 4, 5. Are you with me? Having identified our longest carbon, which is 5, and of course, pent is the name, the ending part of it must end with what? With in. With what? In. So look at the position of the functional group, which is as carbon atom 2. So it will end with pent 2 in. So let's try to name the branch that is in this structure. If I've taken this direction, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it means that our branch is here at where a carbon atom form. And this branch is what? A methyl. A what? Methyl. So how do we name? In that name, 1, 2, 3, 4. Carbon atom 4. We have a methyl. Say 4 methyl. 4 methyl. Then we have 1, 2, 3, 4, 5. 4 methyl pent. A carbon atom 1 to 2 N. Are you with me? So the correct answer to this question is 4 methyl pent 2N. 4 methyl pent 2N. Is that one simple enough? So take yet another question. We have CH3, CH2, C double bond OOH. Therefore, we have A as C. We have propanoic acid. Then D, we have ethanoic acid. All right, we have a question on the board that says, give the IUPAC name of the structure above. Are you with me? This one is quite very simple. The first thing is to what? To identify the longest carbon containing chain, then identify the functional group. Now, students mix up this end. Look at this structure. If I've written something like this, C double bond OOH, if I want to write it in a single file, it can be COOH. This is alkanoic acid functional group. Alkanoic acid functional group. That's carboxylic acid or alkanoic acid functional group. Now, in an alkanoic acid structure, if you want to locate or start numbering the longest carbon, the first carbon, hence you must start carbon from that. What does it mean, or what are we saying in essence? The way it is, or what I'm saying in essence is we must start numbering our longest carbon chain from this end. This C is what? A group of an alkanoic acid family, and so we must start numbering from here. We must give priority to this carbon from the point where we attach to this functional group. So the numbering is 1, 2, 3. Are you with me? And 3, carbon atom 3 is what we call prop. Is what we call what? Prop. So this is simply methane, ethane, propane. You now say propanoic acid. Propanoic what? Acid, or something I can call it propanoic acid. Did you get that? Hello? What I'm saying in essence is this. If you have an alkanoic structure, you must start numbering the carbon atom from the carbon that is present in the functional group. That is the point you must start numbering from. And that carbon that is part of the functional group automatically becomes the first carbon in the structure. So this is 1, 2, 3. 3 carbon atom is prop. And because it's an alkanoic acid family with the functional group COO, you call it, say, propanoic acid. Propanoic acid. If you're just joining us, this is Fame Global. Today, we have been able to answer questions as based on the topic called IUPAC nomenclature of organic compounds. If you have not subscribed, kindly subscribe to our YouTube channel, and we are still there on Facebook, on TikTok, and on Instagram. Thanks for your time. Looking forward to seeing you in some other of our class. Bye for now. Hey, Jesus.